Hi everyone, my name is Daniela Martin and I am a microbiology and biomedical engineering student from Universidad de los Andes in Colombia, and this summer I was an intern in the Genders Lab here at BTI. So this is my research. It's called Adaptation of a Tissue Culture Independent Transformation Method and Genomic Editing Tools for Coffea arabica. And just let me introduce you a little bit into this. So Coffea arabica is the most important cultivar because it represents almost 60% of the global coffee production. However, it is very vulnerable to droughts, climate change, and also some pathogens such as the coffee rust. The conventional method to genetically modify coffee plants and in general plants is tissue culture, but it really doesn't work that properly in coffee plants because it takes so many time doing that. So recently, the last year, Coffea et al. Discovered a new method to modify plants, and it's called fast track or fast treated agrobacterial culture, which uses this gene, Wushel2, and this gene induces the novel meristem formation. Okay, another important thing is that we use this construct is Ruby. So this is a reporter. This is a reporter that encodes the betaline biosynthesis pathway, and it is used as a visual selection marker for transformation in plants. So the main objective of this project was adapting this method, the fast track system, to genetically modifying coffee plants, especially the Coffea arabica cultivar. So it actually includes two other objectives. So first one, we evaluated the different agrobacterial efficiency strains, and we optimized the promoters and inducible systems for the expression of Ruby in the fast track system. So here we were cloning and testing different promoters for the Ruby construct, and we started with this promoter called KCS6, which is a tissue-specific promoter. So what we did was basically cutting the promoter in 7 fragments, and then we put every fragment into this construct called PUPD. Using this system, it's golden braid, so it allows us to go from different plasmids, and then we put this promoter into another plasmid, which is the alpha-2 plasmid, but in this plasmid we also put the Ruby construct and the terminator. So after doing that, finally we had this plasmid right here, and we made the transformation into agrobacterial efficiency. We used these strains, GB3101, and then we infiltrated into Nicotiana pentamiana leaves. So actually the only 2 promoters that we could bring from this point to this point were the KCS6 750 and KCS6 1000, and it actually didn't work in the Nicotiana pentamiana plant, so we didn't see any results. But we were also testing some other promoters. So we had this promoter, it's called NOS. So here we also use golden braid to put the NOS promoter into this new plasmid. This is the alpha-1 plasmid, and we used also this construct, which was an omega-2 plasmid, and then we transformed this into agrobacterial tumefacients, and we made injection into Nicotiana pentamiana. So actually this part over here was already made by my mentor, and here we used the fast track system to inject the pentamiana plants. Another of our objectives was optimizing the inducible system. So here we were optimizing the Gulf-4 UAS inducible system, which uses dexamethasone. So basically this system works because it is bound to the glucocorticoid receptor, but in that case the Gulf-4 can't go from the cytoplasm to the nucleus to start the transcription. So when adding dexamethasone, the Gulf-4 can go from it can go to a nucleus and bind to a UAS sequence and start the transcription of our construct, which is Ruby. So here we were building the whole system. First we started with all the components separately. So we had the UAS, we have the promoter Mini 35S, we have also our construct Ruby, and our terminator in that part. But here in NB we had the GAL4 system. So we had two parts which were domesticated to put them into this plasmid. And after doing that, we made golden braid into alpha 135S. And finally, we combined those two constructs into this one called omega 1. So at this point, we have all our system together. And the next step is putting this plasmid transforming this plasmid into agrobacterium tumefaciens and doing basically the same thing. So infiltration into Benthamiana and then injection into these plants using the fast track system. We also were evaluating agrobacterium tumefaciens strains, and for doing that we used 40 strains of agrobacterium. Those are the strains that we used. And we also used 3 constructs, which are those constructs. So my mentor previously used those constructs, which with the previous steps were infiltration to Benthamiana and then injection. But the next step was injection using the fast track system into coffee plants. So here we are doing this procedure. So for using the fast track method, first you have to remove all the meristems, and you only need to leave only 2 leaves in the plant, and then you have to inject. And this is the before and after doing the injection. So this is our plant before removing all the leaves, and this is our plant after removing the leaves and actually doing the injection. And that's how our plant looks after 7 weeks of doing the injection. So it survived. And after cutting all the meristem and new tissue, we found this. So this is the results after 8 weeks. And here we can see the meristem injection. So as you can see, this is this is a really irregular growth in the plants. So it was induced because this gene, the Wushel gene, induces irregular meristem formation. So that's what it's seeing here. And actually, we only were able to see this result into LBA 4404 with the LBA 4404 strain, which might indicate that maybe this is the best strain to do coffee, to transformation into this strain, into this cultivar of coffee, which is Coffea arabica. So that was the work that we did this summer, and despite the arduous molecular work and doing this project, we were not able to see the results with using the KCS6 promoter. But it may also indicate that maybe the promoter is too short, so we need a longer promoter, because we were able to inject to infiltrate the Nicotiana and Benthamiana plus with only 2 promoters, so it was the 750 and 1000. So probably with the longer promoters we can see the results. And for using the GAL4 UAS inducible system, so here the next step is just transforming to agrobacterium and doing the next steps. And in talking about the strains, we found that the best strain was the LBA 4404. Despite this strain, the EHA 105 is the best strain to do to generate Coffea arabica plants in vitro. But for our system, our adaptation of the fast track system is better using the LBA 4404. And okay, well, after finding the correct promoter and using our strain LBA 4404, we can can have our interest gene to overexpress, and having both plasmids, so our plasmid that induces meristem injection and our plasmid with the interest gene, we can co-infiltrate it into our Coffea arabica plants, and thereby we were screening the transgenic plants in an easier way. So that's it, and I just want to acknowledge my university in Colombia, Universidad de los Andes, and also Rob Canizares, who was funding my summer here. So thank you so much.